a bold dream was born to break records, pushing absolute limits of human automotive engineering. The beating heart of this machine is a colossal 16-cylinder powerhouse of pure fury.
Engineers demanded over 1,000 horsepower to conquer the legendary 400-kilometer speed barrier.
But generating such extreme power created a terrible, invisible monster hidden deep inside the chassis. Unimaginable heat flooded the internal compartments, threatening to melt the entire vehicle into liquid metal. Volkswagen executives faced total disaster as early tests revealed catastrophic failures within the cooling system. Crucial components warped instantly under pressure, transforming this incredible billion-dollar project into a nightmare. Desperate designers scrambled to find solutions for the relentless thermal energy destroying their beautiful prototype. Traditional automotive radiators completely failed to manage the unprecedented inferno erupting behind the driver's seat. They needed an entirely new branch of physics to prevent the ultimate hypercar from melting. They fitted 10 separate radiators into the tight framework to battle the immense thermal energy. Air flowed like a powerful hurricane through the body, taming the fierce volcanic heat inside. Massive scoops on the roof forced colossal waves of fresh air directly into the monster. The active rear wing deployed seamlessly, directing turbulent hot air away from the burning engine. With the thermal crisis finally solved, a brave pilot prepared for the ultimate speed test. The machine screamed down the infinite pavement, hunting for a world record once thought impossible.
Numbers climbed relentlessly into uncharted territory, proving the incredible triumph of modern automotive engineering.
The melting nightmare was officially conquered, cementing a legendary icon safely into automotive history books. A masterpiece forged in fire, the Veyron remains a testament to defeating the impossible. Feeding a 16-cylinder engine required a fuel pump system unlike anything ever built before. The intense heat threatened to boil the fuel inside the lines, causing catastrophic vapor lock. Aerospace engineers designed a highly advanced fuel system to keep the volatile liquid perfectly stabilized. Extreme temperatures from the nearby brakes threatened to burst the specialized Michelin racing tires instantly. At 400 kilometers per hour, tires would disintegrate from extreme heat within 15 minutes.
A completely new rubber compound was forged to endure the punishing thermal and mechanical forces.
Aerodynamics played a critical dual role, providing immense downforce while extracting destructive thermal energy simultaneously. F1-grade thermal blankets were wrapped around the exhaust to protect delicate carbon fiber panels. Every single vent of the body served a critical purpose in this relentless climate war. The Bugatti Veyron was transforming from a simple sports car into a rolling physics laboratory. Specialized chemical coolants were engineered to absorb heat much faster than ordinary water-based systems. The engine oil system doubled as a vital cooling mechanism to protect internal moving parts.
A completely flat underbody channeled high-speed air to pull heat away from the transmission. Carbon ceramic brakes reached temperatures high enough to melt steel during high-speed deceleration runs.
Dedicated cooling channels directed icy air straight onto the blazing brakes to prevent total failure. Carbon ceramic brakes reached temperatures high enough to melt steel during high-speed deceleration runs. Every single production car required weeks of rigorous testing to verify its thermal endurance limits. The engine oil system doubled as a vital cooling mechanism to protect internal moving parts. The pride of the brand depended entirely on conquering this massive and complex engineering challenge. From straight-line speed to tight alpine curves, the cooling system handled every stressful environment. The engineering crisis was fully averted, giving birth to the ultimate king of modern hypercars. The dual-clutch gearbox faced extreme friction, requiring its own dedicated thermal management cooling circuit. To prove its ultimate durability, prototypes were driven straight into the hottest deserts on Earth. Despite punishing exterior temperatures, the internal engine block remained completely stable and remarkably cool inside.
Testing facilities consumed massive amounts of electrical power just to simulate hypercar atmospheric wind resistance.
Microscopic structural analysis ensured the titanium components would never fail under intense thermal expansion cycles.
The banked curves of the secret test track provided the ultimate proving ground for safety. Slamming the brakes deployed an aerodynamic shield, bleeding off kinetic energy and shedding extreme heat. 4 distinct turbochargers spun at furious speeds, forcing compressed air into the roaring combustion chambers. Marrying the colossal engine block to the chassis was a delicate mechanical ballet of precision.
Countless sleepless nights finally culminated in absolute victory over the brutal laws of thermodynamics today.
Pure gold lining reflected the brutal thermal radiation away from vulnerable carbon fiber body panels. Advanced air intercoolers rapidly dropped the temperature of incoming oxygen to maximize explosive engine combustion.
A complex water jacket surrounded each individual cylinder to absorb devastating internal friction generated instantly.
Designers purposely left the massive engine exposed to the open sky for maximum heat extraction.
A specialized dry sump lubrication system kept vital components perfectly coated during extreme high speeds.
Intelligent computer algorithms constantly calculated optimal fuel mixtures to prevent spontaneous internal cylinder detonation events.
Deep-side intakes swallowed enormous volumes of surrounding atmosphere to sustain the vital cooling matrix.
Massive exhaust ports violently expelled burning gases to reduce the crippling back pressure building underneath. Military-grade composite materials were rigorously tortured to guarantee they would survive the brutal heat.
The unbelievable engineering solutions created for this singular machine changed the entire supercar industry forever.
Advanced thermal cameras captured the magnificent heat dissipation process operating flawlessly during maximum velocity testing.
3 distinct high-performance water pumps forced gallons of fluid through the massive aluminum network. Even the front grille mesh was specifically engineered to avoid restricting crucial forward airflow momentum. The sophisticated transmission required its own independent heat exchanger to survive the brutal torque delivery. Freezing Arctic temperatures provided an opposite extreme to test the resilient components against thermal shock. Over 40 liters of specialized synthetic oil constantly circulated to cool internal rotating steel masses. Engineers meticulously calibrated digital warning systems to monitor the complex thermal equilibrium without frustrating drivers. Ceramic-coated exhaust manifolds prevented radiant energy from melting the delicate wiring harnesses installed nearby.
Combining 10 distinct radiators created an entirely new benchmark for automotive thermal efficiency and endurance.
Safely returning from a top-speed run, the hypercar emitted visible heat waves without braking.
Keeping the human driver comfortably chilled required an air conditioning unit powerful enough for apartments.
Aerospace-grade silver shielding protected vital electrical communication wires from instantly turning into melted plastic.
Specialized turbine wheel designs acted like giant vacuums, pulling trapped boiling air outward during acceleration.
Pressurized titanium expansion tanks absorbed the violent volumetric swelling of boiling liquid under extreme stress. High-velocity electric cooling fans automatically activated when heavy traffic threatened to suffocate the engine. Post-drive heat soak remained a massive danger until auxiliary pumps circulated fluids after shutdown. Millions of lines of custom code governed the intricate symphony of active fluid cooling dynamics. Multi-layered silicone hoses contained pressures that would easily rupture standard commercial automotive rubber pipes. Advanced synthetic lubricants miraculously maintained perfect viscosity while operating at unbelievably punishing high-temperature extremes. Once fully synchronized together, these individual mechanical miracles formed a beautifully indestructible thermal management shield. The engine block itself was cast from a unique aviation aluminum alloy to survive heat. Specialized spark plugs delivered massive electrical voltage without melting inside the furious internal combustion storm.
Exhaust gases exited the cylinders with such extreme violence, and they functioned like small rocket thrusters.
Final engine endurance tests required running at absolute maximum throttle for hours inside sealed rooms.
Even the smallest structural fasteners were forged from titanium to resist severe heat expansion warping. The aggressive front splitter literally carved the dense atmosphere, funneling freezing air toward thirsty radiators. Any external moisture touching the
Examining the vehicle after brutal endurance runs revealed zero signs of dangerous component heat degradation.
Volkswagen had successfully transformed a volatile, explosive engineering nightmare into an elegant masterpiece of luxury. Delivering the first production model finally proved their seemingly impossible thermal theories were absolutely correct. Unlocking maximum velocity required a specialized secondary key to prepare the ultimate aerodynamic cooling configuration. The chassis automatically dropped toward the asphalt to slice through massive walls of air resistance. Pressing the throttle unleashed the full fury of the 16 massive combustion chambers completely safely.
Searing heat was instantly swept away as the legendary machine rocketed toward its historic destiny.
Achieving over 400 kilometers per hour demanded absolute perfection from every single cooling mechanism.
Decelerating from such extreme speeds generated enough kinetic friction to power a small residential neighborhood.
The ticking metal proudly signaled a successful cool-down process without a single catastrophic mechanical failure. Looking at their creation, the design team knew they had achieved absolute automotive engineering immortality. The Veyron's spectacular success paved a golden road for all future generations of Bugatti hypercars. Headlines across the globe celebrated the incredible triumph over impossible physics and molten metal nightmares. Driving this masterpiece today remains a testament to those who refuse to accept thermal defeat. The massive 16-cylinder engine stands proudly today as a beautiful monument to human perseverance. Few machines in modern history will ever demand such an extreme evolution of cooling technology. The legendary crisis was completely defeated, securing a permanent throne for the ultimate speed king. This was the spectacular story of the Bugatti Veyron and its miraculous engine melting crisis.